And the first thing we realized was that the supermassive black hole in the center of our galaxy, Sagittarius A star, had a size that was predicted by this shadow feature. So 100 years ago, Einstein came up with this idea that a black hole would cast a shadow, and we saw exactly that size. And because the whole reason for doing this is to look at the size and shape of that shadow, predicted again by Einstein, to test whether Einstein's theories break down at the edge of a black hole, and also to study the dynamics of matter around the black hole. So the Event Horizon Telescope is a project dedicated to the notion that we can see something that we've always been taught is unseeable. Right? So everybody knows that a black hole is something that absorbs light, matter, nothing can come out from the event horizon once it's gone into the event horizon. But because all the gas and dust is heated up and you get this effective three-dimensional flashlight all around the black hole, illuminating it from all angles, you can see its shadow or the silhouette that it casts against all that hot gas.
So what about Interstellar? Do you know how in Interstellar they show the disk around the black hole, but you can kind of see it above and below? You know, you imagine the three-dimensional drum of space-time is ringing in response to this kind of chaotic event. So in that sense, it might have, made, in a sense, a noise that if we could record the shape of the ringing drum, we would interpret a sound.
Okay.
Even in the absence of air.
So whenever a black hole heats, it changes its shape slightly, and that changes the gravitational waves that it's emitting.
And also around the black hole, the accretion disk can support sound waves, can't it? So this disk that you were describing of all this material falling in around the black hole and flattening it out, it can have a sound wave through that material.
As long as you think of sound waves not as being something we can hear with our eardrum, but as being waves mediated by some kind of medium, like gas or dust or something. So black holes, what are they?
What are they?
Well, everyone has some idea of what a black hole is, but essentially it's when gravity's run amok. It's when mass collapses in on itself to the point where gravitational runaway is inevitable. And nothing can keep matter from infalling to a singularity, to a point. Mm-hmm. And the interesting and defining thing about a black hole, and this is what we all probably know about, is that there's this membrane called the event horizon around the black hole. And that's the point outside the singularity where gravity is so strong that even light can't escape.
And that's named after the movie.
It's the other way around, actually, but it's what most people think about when they think about the event horizon, the movie, and the spaceship that went into hell and then came back out haunted.
So the event horizon means no events that happen on the other side of that line will ever be known to you.
So black holes, what are they? It's when mass collapses in on itself to the point where gravitational runaway is inevitable. And nothing can keep matter from infalling to a singularity, to a point. Mm-hmm. And the interesting and defining thing about a black hole, and this is what we all probably know about, is that there's this membrane called the event horizon around the black hole. And that's the point outside the singularity where gravity is so strong that even light can't escape. It's the other way around, actually, but it's what most people think about when they think about the event horizon, the movie, and the spaceship that went into hell and then came back out haunted.
Okay.
What
happens in the event horizon stays in the event horizon.
It's the weirdest.
Supermassive black hole, like the ones that are in the center of our galaxy or in other galaxies, you just pass right through the event horizon like it's not there, but you can't get back out again. Mm-hmm. We're probably seeing it as it's eating, as it's driving these jets from its north and south pole through the galaxy. And they think that what causes that is that 300 years ago there was a burst of activity in the center of our galaxy, and the shock wave has reached the clouds that bound that area, and it's fluorescing.
So speaking of which, we're seeing the black hole 25,000 years ago, as it was then.
So there was a cloud of gas that they thought was about 3 times the mass of Earth, and it was falling into the black hole. And,
did it just not fall in?
A lot of it depends on how you engage the black holes, and it might take a long time for the gas that you're contributing to the black hole to find its way all the way to the event horizon where it would light up.
Blair Jackson on Facebook asks, could the Big Bang be the birth of a black hole?
When we look back at the Big Bang, we might be looking back at the singularity inside a black hole. I mean, this is what all theoretical physicists pine for, is a resolution of the theory of gravity with the theory of quantum mechanics. So the large theory of the universe on the large scale and the theory of the universe on the small scale. They're very hard to put together. Even if I went through kind of a standard program, this is what I always do when I try to quantize a model of the universe, it doesn't really work with gravity because gravity is so nonlinear. Right? This is not, the effects feed back onto themselves in these very complex mathematical ways that we don't know how to control. So literally, we just don't know how to write it down. It doesn't mean it doesn't exist in reality, but we just don't know how to mathematically write it down. Our tools fail us. And so many people have tried just to find better tools, but it might be the case that they're actually not reconcilable in nature, that gravity, in some sense, isn't a fundamental force.